It's been a while. Welcome back to my series on programming in assembly language on the Atari 8-bit computer with the Mac 65 cartridge. Today we're going to take a break from the program game demo that we've been working on and spend the next couple videos talking about the ANTIC chip and specifically the display list and how to do custom display lists in assembly language. And we are going to build towards the goal of using that to go to a mode in ANTIC called ANTIC Mode 4, which lets us do the same kind of characters we've been using now in Graphics 1, except we can make them 4-color characters. So, and that mode was used heavily in a lot of Atari video games, in the 80s, the ANTIC Mode 4. Like, I'm pretty sure Montezuma's Revenge is one of them. So, anyway, we're going to get started with display lists. So the way I'm going to structure this video is a little different. I'm going to do all the assembly code up front, and then the back half of the video I'm just going to talk about specifically the ANTIC chip and how it works and what the instructions are and the different modes, and do a real deep dive on the ANTIC chip. So I'm putting the assembly stuff first, so if that's all you're interested in and you know how the ANTIC chip works or you don't care, you can skip the back half of the video. Or if you've seen it in the action series, I did that ANTIC deep dive as well. So we're going to do the assembly language stuff first. We're going to write a brand new program tonight, just a little display list interrupt demo, not interrupts. We're not doing interrupts yet. That's coming. A little custom display list, custom display list. That's what we're gonna write tonight. Brand new program. So the first thing we're gonna do is we're gonna create 2 new macros that we're gonna use in the display list demo program just to make our lives easier. So if you remember right now, we have set color, we have something that assigns a value to a 2-byte address, and we have a delay macro, and we're going to add 2 new macros in our dog park program. We have a section of code in the setup portion to open a Graphics 1 screen. What I want to do tonight is write a graphics, but instead of making it a subroutine, I'm going to make it a macro, a graphics macro that will mimic the graphics command in BASIC or action, and it'll take one parameter, which will be the graphics mode that you want to open. We're not going to put any real error checking in it. We're just going to assume that you're going to give it a valid graphics mode. But the one that we had in the program already was specifically for Graphics 1. This one will take any mode that we give it. So let's get started on that. And as always, when creating a new macro, we start with the macro name and the macro compiler directive. So we start with macro graphics, we're going to call it, so it looks familiar to us. And this part is just really mostly a copy of what we have in our other routine. So we're going to load the X register with 60, which will do an offset for the IOCB blocks. So this says use IOCB block 6, which is, well, technically it's IOCB block 7, right? 0 to 6. And that is dedicated to the screen device. So we say load the X register with that to say for the screen. And before you open the screen, you always have to close the screen. So this is the close command. We're storing the close command at icon. And again, we have to make sure that since we're using these, that we have defined them somewhere. And then we're going to just jump to the central input output vector subroutine to close the screen for us. Now that we closed it, we're going to open it. We want to make sure that that subroutine hasn't put some other value into the X register, so we're going to copy that over again. And now the command is 3 is the open command. Again, you remember we have in our other, this is the address of a buffer that holds the device name. So this is going to be in our demo program. It's going to be S: for screen, and we store that at buffer address low, the low byte. And the high byte of, now right here, this is screen, which is, S:, but I could have defined in my thing, in my other program, so let's say I wanted to use channel 1, and instead of screen, I used file name, and in my program, I could have, instead of S:, I could have D2: file name. And this is the high byte of high. And then we have 2 special commands. So the first one says pass a value of 12. That's read-write mode. We want to be able to read and write to our screen. And I'm sorry, this is a review, but that's how it goes. And then here's the actual thing that comes from the macro is this is goes in auxiliary byte 1. This is the part that is our macro, so we're going to use the low byte of our parameter, which is going to be our parameter is going to be the graphics mode that we want. So this says get the low byte of that graphics mode, and that we're going to store in auxiliary byte 2. And then once we do that, we just jump to the subroutine, And that's our whole macro for doing graphics modes. So again, to open a screen in Graphics N, we want to make sure we're using channel 6, which is the screen. This is close the screen command, store in icon and jump. This is the open command, put that in icon. Give the device name in the buffer address. Oh, that's a big mistake I've been making in previous videos, and I called it out in a comment on the last video, but forgot to mention it in this video so far. Big mistake I've been making is I've been saying this is the buffer length, low and high. It's not. That A is for address. This is the address of a buffer. So in this case, it's the address that's holding the device name, which in this case is screen S colon. So this is address. Get the address of the device name, not length. There's an actual one for length, which we'll look at in our second macro today. All right. Then this is hard-coded. 12 is read-write screen. See a previous video for what that means. Put that in auxiliary byte 1. Get the graphics mode, get the low byte of that, because it's always going to be graphics 0 to 15, and then jump, store that in auxiliary byte 2 and jump, and then that's the whole macro. Now, the other macro that we're going to do is we have created a subroutine that puts a single character on the screen, and we've created a subroutine that gets a single character from the screen. Now we're going to write a macro that prints text to the screen. Now we kind of did that in the initial hello world, but in that case we had a buffer and we were iterating over the buffer. We were not using the central input-output vector. That's what we're going to do here. So we are going to write a macro to print to the screen. So and we're going to do this using the central input-output vector. So instead of getting a single character or putting a single character, now we're going to put a string of characters, and we're going to call this, again, we need a name. We're just going to call it print, not print Q. All right, and this is going to print at a specific place on the screen. So it is, we're going to tell it where to print by setting up the X and Y registers. Before we call this macro, we're going to set the X and Y registers with the X position on the screen and the Y position on the screen that we want our text to appear. So we're going to count on the fact that that X register has already been prepped when I call this macro, and that the column cursor has been defined with an address for that, and we're going to store Y at row cursor. Again, we're going to, this is specifically to print to a screen. We're just working with the screens right now. So we're going to load X with channel 6. That's why I'm calling this macro print and not put record, because put record would be more generic and allow me to put a string to the screen, put the screen to a disk drive, put the screen to a cassette player. We're going to work on that in a future video. Right now, we're just worried about printing to the screen. But it does use the command don't want to forget that. So 9 is the put record command. And that goes in ICOM X. And we're going to, the first parameter is the string we want to print. That's going to be our buffer address. So the place where we stored the string in memory will have an address, and we're going to put that in buffer address low and buffer address high, and that's going to be our first parameter. So we're going to get the low byte. Oh, come on, man, you're killing me, Smalls. I hate when I'm holding down the control key and I hit the less than. Yeah, I didn't want that. Okay. So we're going to get the low byte of our first parameter, which will be the address of the string that we want to print. Put it in buffer address low. Take the high byte of the address of the string we want to print and put that in there. Now we're actually going to use buffer length. So we're going to take the low byte of the length that we want. So our second parameter, and we're going to store that at ICBBLL, which is, this is buffer address, this is buffer length. So I won't be making that mistake again. And actually, we're printing this on a screen. We're not going to print any text modes where there's going to be more than 255 bytes, in a text string that we're going to print to the screen. So we can set the high byte directly to 0. Buffer length high. And then let's just list. All right. And then all that's left is to jump to the CIOV subroutine. So we want to print at column cursor and row cursor. That's where our string is going to start. That's like a position statement in graphics. So if I'm printing to a graphics string, think of this as the position statement, position X, Y in BASIC. Then I'm going to set this to use the put record command and load it with the buffer of the string I want is my first parameter, and the address or the length of the string I'm going to print, I'm going to put in here, and then I'm going to call this. Then I need to end my macro. come on. That's what I don't like. So there's our graphics macro. There's our print to screen macro. And we're going to save that. Now I added 2 macros. I can still use this include file in my dog park program, because remember, if I don't use a macro, it won't compile into the code. So it won't try to compile any of this code if I don't actually use these macros. So it's okay to have extra macros sitting around in a file. All right, so now we're going to start our new program. And again, I think I mentioned this in an earlier video. I'm always going to put my macros up front for Mac 65 because they can't be after any usage of them. This makes sure that that doesn't happen. For now. All right, so we're going to add some system defines here. One that's going to be important for us to use today. Now, there's 2 ways to get a custom display list. One, you can build the whole display list yourself, and we're going to do that probably in the next video, your whole display list. Or you can set up a graphics mode, like using the macro that we just defined, to set up a graphics mode. When you do that, you call that central input output vector subroutine, and it creates a graphics mode. It sets aside a place for screen memory, and it creates a display list for you and sets it in memory. And the other way, instead of creating your own custom display list from scratch, you can let the system create a display list and then modify the display list that it created. And we're going to go in more detail about how to do that in the next video after I explain how the ANTIC chip works. So tonight it's mostly just going to be, I'm going to show more than tell, but the one address that we're going to need is STL, which is the address that points to where the display list is located. So after I call my macro routine to set up graphics mode 1 or 2, 8, 7, or whatever, if I look in this memory address, that's going to tell me where the display list is located. So we're going to need, as I said before, we're going to need column cursor, which is 55, and row cursor, which is 54. And this we're just going to have in there so I can put a nice exit point for my program. I'm just going to check when this demo, I'm just going to check when they press start like we did in the other one. So those are the only ones we're going to need tonight, except for our IOCB defines. Again, we don't need all of them tonight. We need the subroutine address, which is at E456, which is nice and easy to remember. And then we need icon. we need ICBAL. ICBAH, buffer address, ICBLL, buffer length, auxiliary byte 1 for the graphics command macro. I'm only gonna have one program variable, and I specifically very much want it in 0 page. So and that is, I want to be able to move the address of I want to be able to move the address that I find in 230 down into D4 and D5. And the reason I would do that is I want the pointer to the display list in the 0 page, so that when you'll see it in a minute why I'm doing that. And then this will be my real program start. So you've seen this trick in the previous videos. Again, I start all of these with begin. And I'm going to use my macros here. So I'm going to just say graphics 1. We're going to use the same colors as we did for the dog park program. So I'm going to use my set color macros. You can see how that can speed things up for you, all right? Now what I'm going to do is I want to copy the into my 0 page holder for it. Now, at this point, I have a graphics 1 screen with a display list set up. What I'm going to do is, and I'll explain this in more detail next time, but I'm going to override what's in the display list in memory using the indirect indexed Y mode that we've used in the past. So what I want to do is I want to take the 7th instruction in the display. I'm sorry. I want to load this with load the accumulator with ANTIC mode 7, which equals a line of graphics 2 code display. And I'm going to put it in the 8th instruction in the display list. So when I set up this graphics one, it created a display list where the ANTIC instruction list said, display all these lines in graphic one. Well, I'm going to go down to the 8th instruction from the top, and I'll explain how I got there in the back half of this video. I'm going to go down to the 8th instruction from the top, and I'm going to store a 7 in there, which says use graphics mode 2 on that line only. So I'm going to have a whole screen full of graphics 1, but I'm going to have one graphics 2 line in there. Difference between graphics 2 and graphics 1 is it's got the same height, but the characters, it's got the same width of characters, but the characters are double height. So instead of being 8 scan lines high, it's 16 scan lines high. You'll see in a minute. So it's the I think that's right. So the 8th ANTIC instruction in the ANTIC display list actually corresponds to the 4th screen line. So, and then what we're going to do is we're going to say, hey, in column 4, right, 0 to 3 is, so 3 is 0, 0. First column is column 0 to 3. So this is in column 4. Row 5. Yeah, I want row 4. That's the one I changed. So this should also be a 3. And yeah, glad I saw that one. And then load X, load Y, and then call my macro print. And this is going to be my graphic 2 text line, and it's going to be 12 bytes long. You'll see when I write it. And then right below it, now notice the difference here is the 8th instruction in the ANTIC display list corresponds to the 4th screen line. But when I'm doing the, so 0, it's actually the, that's the 9th ANTIC instruction. Sorry about that. Right, 0 to 8 is 9. So the 9th ANTIC instruction corresponds to the 4th screen line. I'll show you why later. This says column 4, row 4. This is column row 5. So when I'm doing the column cursor, row cursor, that's actual screen location. It has nothing to do with the ANTIC instruction list. And then this is going to be some graphic 1 text. This is just our infinite loop. This is for our file name for the open screen command. This is going to be our Now, if you remember way back to our Hello World demo, we were using S-byte for our strings. S-byte is for screen memory, and the difference is in the Hello World program, we were poking directly into screen memory. So that needed S-byte to translate this text into a byte that can be displayed, poked straight into screen memory. This says, since we are printing this text using the central input-output vector put record routine, we just use the regular strings for those. Let me just list this to make sure auto numbering didn't do anything weird to me. All right, so we have our title, we have our include, we have the system defines, the IOCB defines. We're going to hold a 2-byte address for the display list pointer in 0 page, so I can use that. So I can use this mode basically to get into the existing display list. We call graphics 1, we set the colors, we copy the display list pointer into the 0 page address so I can use the indirect indexed addressing on line 550. We're going to say use ANTIC mode 7, which is graphics 2. And we're going to stick that into the 9th ANTIC instruction of the graphics 1, default display list. And then we're going to print graphics 2 text on that row. And then we're going to print graphics 1 text on the row under it. And then here's our thing. So I think that looks okay. I don't see any mistakes. Let's save that. We're going to check for clean assembly. Now, just one thing I want you to see here. So like this delay macro calls this label our real-time clock, which we don't have in our display list program. That doesn't matter since I never call delay in my display list routine. This code never gets into the code, so it won't throw any kind of errors. So that's why I say you can include a lot of stuff in your macros. So let's see how this looks. All right, so we did get a clean compile. Making sure I didn't. All right. I'm going to skip the. All right, DDT. And then we have our custom display list. So I have taken the default display list and changed what was normally a graphics 1 line into a graphics 2 line and left all the other ones before it and after it the same. Now, I want to show you a couple things here. So, one problem with this print macro, and I'm going to change it, I'm going to show you, is if I get the lengths wrong, so like if I had the length was too short, then I'm not going to get all the characters. If I have the length too long, so like so if I say the length is 15, but there's only 12 characters of text in my string, and what's going on here? Well, what happened is I said there was 15 characters long, so it said I'm going to start at graphics, graphics 2 text. I'm going to put the first 12 characters, and then I want 3 more. And so what you see happen, it'd be nice if I just remembered these lines so I could just go there. So what I want is 570 onwards. Okay. So what happens is, it says, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I need 3 characters. Well, to the computer, even though I put these on 2 different lines and 2 different labels, they're still stored contiguously right after each other. And so the next 3 characters, it grabs the first 3 characters of this line. And then for this one here, it grabs a 1 after this. I'm not sure where that's from. It could be, just random memory from there. So the problem with the macro as I have it right now is I have to know the length every time and specify it as a parameter. So I am going to show you a way to get around that, and the clue is on line 700. But first, let's change this back to the working version for now. And let's go modify that macro. Instead of having a second parameter that tells the length, what we can do is pick some arbitrary length that's going to be the maximum length that we would expect of the string. And since we're printing on a graphics 1 screen or a graphics 0 screen where I might have 20 or 40 characters, we're going to assume that the maximum length could be, instead of taking a parameter for length, we're just going to assume the maximum length that we would get is 40. And for once, I'm going to be lazy and just do it. We're actually going to say 39. Oh, you know what? I'm not going to be lazy. There we go. So we're going to say the maximum length of a line is 39. And we don't need the second parameter anymore, so we're going to get rid of that. You thought I was going to cursor away without hitting return on that line, didn't you? And here's the trick that we can use that makes this work. This is the Atari end-of-line character, 9B. You see it up above for the screen device. And what that says is when it doesn't know, or when it runs into this 9B, that's like a stop to the put record command. That's an end of line. So I'm putting a record, and if I run into a 9B, it will stop. So even though I'm saying the buffer length is 39, it's... See, now I never trust myself anymore. Okay. So even though I have a buffer length of 39, it only prints the first 12 characters because it hits that end of line character. So we're going to leave our macro the way it is that we did it, and we're just going to make sure that we use that. We're just going to make sure we use that 9B at the end to end our lines with our macro. All right. That concludes all we're going to talk about the assembly programming part today. So we created a macro for graphics. We created a macro for print to screen. And we wrote a short little program that modifies an existing display list to throw a line of graphics 2 in the middle of a graphics 1 screen. The next couple minutes, I'm just going to talk about the ANTIC chip. So if you are only interested in the assembly language part, you can check out now. All right. Now, I actually have found a use for the Atari Mac 65 text mode. Whee! It turns out that if I go into text mode, I can enter a text file that is not a valid assembly file. So it's not going to do any error checking on me. But and remember, if I do an enter, it's not like BASIC. It's not going to merge the code. It's not going to merge the file I enter with the existing code. It's going to be like I type new and enter. All right, so let's talk about the ANTIC chip. The ANTIC chip is a separate chip like the 6502 that sits in your Atari, and it's responsible for drawing things on the screen. When the Atari first came out, it was meant to be hooked to a regular cathode ray color television set, not the super video HDMI TVs we have today. They had lower resolution, and they had what they call overscan, which meant the picture went outside the boundaries because nobody wanted to see a black border around their screens on their TVs in 1980. So Atari displays are built to be displayed on the technology that was available at the time. The ANTIC chip takes care of this display that you're looking at right now. It's a totally separate chip from the 6502, and it has its own programming language, and it runs separate from the 6502. In fact, when it's doing its thing, the 6502 is not doing its thing, and it's sleeping. So the more intricate your display list stuff is, or how long your display list is, or how much memory your display uses, and how many scan lines can actually affect the performance of the 6502. You may have seen way back in the day in the magazine programs that were written in BASIC, anytime they had to do a lot of data loading or setting up player missile graphics, whatever, they turn off the display. And then they do the data in the background. The reason they turn off the display is to make it faster. It's because when the display is off, if you turn off the ANTIC chip, which you can turn it off and turn it back on again, when you turn off the ANTIC chip, it's not stealing any time from the 6502, and the 6502 is running free like Maria at the start of Sound of Music, just gobbling up all the CPU time it wants, not sharing like it normally does. All right. So the ANTIC chip controls the display on your computer with a set of instructions and or modes. So the instructions and modes on the 65 or on the ANTIC chip, there's only 16. That's it, 16. Which means it's only the lower nibble. So every instruction in an ANTIC display list. So a display list is like an assembly program. It's a set of instructions to the ANTIC chip that starts at the beginning and runs through the instructions until it gets to the end. And then there's a jump, or loop, back to the top, and it does it again. And it's the same way that your screen is being drawn. So how a screen gets drawn on the Atari is it starts up in this corner, it goes across, it's drawing it's drawing this whole screen by writing a line down to the end and then turning it off, coming back to here, turning on and writing another line. So all of this screen is being drawn 60 times a second by a bunch of lines that are going across the screen, and those are called scan lines. The Atari, since it was built 8-bit, since it was built for TV sets, it has like a default resolution of 100. Where's my notes there for that? It has a default of 160 pixels max, 160 pixels across, and 192 scan lines usually visible. So these are 192 different scan lines. Each instruction in the ANTIC chip can take up a different number of scan lines, but of the visible ones here outside this border, there's 192. There's some above here, and there's some below here, and there's 160 across, and there's some that come before here, and some that come after over there. But the visible ones, it's 192 by 160. In graphics mode 8, it will increase the horizontal resolution from 160 to 320. And on modern displays like this one, this is capable of that resolution. So it's like an HDMI or any other, like a Commodore monitor, is capable of displaying that 320 resolution instead of 160. But television sets didn't have that resolution. And so what would happen is if you used 320 pixel line on a TV that can only display 160, then it would display pairs of pixels in different colors. So that's like how Ultima 4 on the Atari 8-bit is able to get high-resolution graphics in different colors on a television set, but then when you look at it on a modern computer, the colors are all screwy and it looks just like a bunch of vertical lines, because Ultima 4 was counting on the fact it was going to be shown on a TV set and not on a regular, not on a kind of monitors that we have today. Anyway, getting off track here. So there are every instruction in an ANTIC display list. So a display list is a set of instructions to ANTIC on how to display the screen. There are only 16 different instructions and modes. They're all contained in the lower nibble of the byte, and every instruction to the ANTIC display list is 1 byte. And only the lower nibble is the one that tells the actual instruction. The high nibble is used for various things that we'll get into. Okay, so let's talk about what these instructions are. The first instruction or mode is just all these bits are 0. And when these 4 bits are 0, that's an instruction to the ANTIC chip to display some number of blank scan lines. So what you're seeing up here, these black above, these are blank scan lines that are being drawn so that the actual visible part of the screen shows up, on the screen or on the television set. The number of blank lines, blank scan lines that are drawn is dependent on these 3 bits. This top bit is always 0 for this instruction. So these can be from 0, all these are 0, up to 7, 1, 2, 4, 7. So it can be from 0 to 7, which means 1 to 8 blank scan lines. So if all 3 of these were 0, then it would draw 1 blank scan line. If all 3 of these are turned on at 7, that means draw 8 blank scan lines. Most ANTIC display lists, or all the default ones, always start with 3 of these instructions to draw blank scan lines, and it always says draw 8 blank scan lines 3 times. So, oh, very nice. Even shows up better. So these blank scan lines up above, are part of the 24 blank scan lines. So there's lines up above that you can't see. So every ANTIC display list that is generated by the computer itself will start with 3 70s, which is really instruction 0 with 7 to get 8 blank scan lines. So you'll see it as 70, but ANTIC sees it as blank scan lines. I'm going to draw 8 of them. The next instruction in the ANTIC chip is the 1. This resets the ANTIC program counter. So just like the 6502 has a program counter, ANTIC has a program counter. So at the start of these 3 blank scan lines, the program counter is 0. After it draws those 3 blank scan lines, 3 sets of 8 blank scan lines, right, 24. After it does those 3 instructions, the program counter for ANTIC would be at 4 and would be pointing to the next instruction. So ANTIC has a program counter just like the 6502. This 1 is a jump. It says jump to, and it's always followed by 2 bytes. So there'll be this instruction followed by 2 bytes. This 1 followed by 2 bytes, and that says go there to reset the ANTIC program counter to 0, and then go to this address that's going to follow this 1 and start drawing the display list again. There are 2 flavors of this. The first one, the most common one, is when this bit is set. This is the load memory scan bit. And when this one is set with this instruction, so 41, then it says reset the ANTIC program counter and go to the address to get the display list of, the display list. I keep saying DLI there. It should just be DL for display list. So ignore the I there because we're not doing interrupts yet. So please excuse me where I have I there. It should just be DL address for display list. But anyway, reset the program counter, go to this address, and start executing the instructions there. Normally, this instruction is the very last one in your ANTIC display list program, and it basically will say jump to the top. When this bit is set, it says jump to this new address at the vertical blank interrupt time, which means when it gets to the end of the line and it comes back over here to start again, this is a horizontal blank. When it's drawn all of these and got all the way down to the bottom and has to turn off and go all the way back up to this top corner, that's the vertical blank. So this will usually be the last instruction, 41, followed by an address, which will usually be the start of the same display list, 3 blank line, 3 blank, 3 sets of 8 blank lines, etc. And do it at the vertical blank interrupt. So it gets down to the bottom of the screen, it hits that instruction, it waits for the vertical blank to start going up to here, it resets program counter to 0, and starts at that address and goes. That's the most common usage. This one is rarely used. And what this does is you're in the middle of executing these instructions. It's still a jump followed by 2 bytes for an address, but it says go there right now, even if you're in the middle of the screen. Don't wait till you get down to the bottom. Jump to a new display list. That's very rarely used. There's only 2 times you would really use this. One is if you somehow created a display list that was over 1K big, because the 6502 program counter has 16 bits, but the ANTIC program counter only has 10 bits, so it can only count up to 1K. It can't count higher than 1K. So if you wanted to have a display list program that was longer than 1K, then you'd use this jump to a new address and reset the program counter so it could start executing again from wherever you jump to. So, but, you know, most display lists are not going to come anywhere near, trust me, 1,000, right? There's only 192 scan lines. Even if you had a different instruction for every scan line, you're not gonna run out of, you're not gonna hit that 1K boundary. Especially, I guess, you could hit it if you were not careful about where you put your custom display list, but we're gonna make sure we always put our custom display list starting on the boundary so that we don't have to worry about ever using this instruction. The only other time you might use this instruction is if you had a bunch of custom display lists, like maybe 3 or 4 custom display lists for some special effect you're doing, and you want to jump to a new display list in the middle for some trick you're doing. We're never going to get anywhere near that, I don't think, at least. I don't know when we would, but so don't worry about this one. 41 is the one that you'll most see, and it always comes at the end. After the blank scan lines instruction and the jump instruction come all the text and graphic modes. So we have text modes, and when I say mode here, I'm talking about ANTIC modes, not graphics modes. So we have graphics 0, graphics 1, graphics 2. But there's actually 2 through 7 text modes. So there's actually 1, 2, 3, 4, 5. There's 6 text modes, but graphics 0, 1, and 2 are available through CIOV or basic or action. These ones here, well, in the XL and XE, you can now access them. They have their own graphics modes, like 13, 14, 15. I forget what they are. But, so let's just... I just want to go back here and talk about these so for these instructions here, this one is always 0. These are always 0. These could be 0 to 7. This is going to be 1 or 0. From here on down, what these do is what these do here are, these are flags. So these are flags to enable scrolling on a line. This fine scrolling. This is horizontal scrolling, which means your line can scroll back and forth. This is to control vertical scrolling, up and down. So back and forth, it's 1 pixel at a time. Up and down, it's 1 scan line at a time. We'll talk about scrolling in a later video. Just know right now that they're always, they have different meanings for these 2 instructions, but for all the modes afterwards, this enables horizontal scrolling, this enables vertical scrolling, this enables an interrupt on this line. So if you want to do a horizontal interrupt, you set this flag. So like if at the end of the line I want to do some display list interrupt, That's where the interrupt part comes. Then you could set this flag to have it check for an display list interrupt routine. That leaves this one, load memory scan. This is going to be, when this is not set, it just tells the ANTIC chip to display a line of whatever this graphics mode is. Graphics 0, ANTIC mode 3, ANTIC mode 4, ANTIC mode 5. If it's a 0, it says just draw one line of that mode. And most of the lines in your display list instructions will be will be 0. But right near the top, you'll have one where this is turned on, which is called load memory scan again. And that says, for this, I want you to draw whatever mode this is. I'm just showing it for graphics 0, but it could be set for any of these modes. If this is set, it's going to be followed by a 2-byte address of where screen memory is. So this will be usually an ANTIC display list will look like this. The first 3 bytes of the ANTIC display list will be draw 8 blank scan lines. So that takes up the first 3 bytes. The next 3 bytes are going to be load memory scan with whatever graphics mode you're in. So like in the graphics mode 1 screen, that value after the 370s, which are 8 blank scan lines, will be 370s. Then there's going to be a 46 in the display list, which says, hey, I want you to display graphics 1, and I want you to grab the screen memory from the 2 bytes that follow. And again, when we call the central input-output vector, that's screen memory address is stuck into the display list for us. We don't have to calculate it on our own. When we build our own display list with our own screens, then we'll have to worry about filling that value in. So the first 3 bytes are 8 blank scan lines. The next 3 bytes are going to be draw a graphics mode, ANTIC mode of some kind, and take the next 2 bytes for screen memory. So that's 6 more. And remember that 4th byte with the 41 or the 46, that's the first value on the screen. And then the next ones will all be blank, will not be blank. There'll be mode lines with this value 0, which says just draw the mode line. So in that demo program where I was changing the 9th, I used 8, but it was the 9th line. That meant 3 blank scan line instructions, 3 bytes of instructions for the 46 for the first line of graphics 1, and then the memory address 2 bytes, and then the next 3 bytes are going to be line 2, 3, and 4. So the 9th byte down is the 4th byte. That's where I got that from. So all the text modes, the high bit in the nibble is 0. So if this is 0, this is a text mode. If it's a 1, this is a graphics bit mode. So here, ANTIC sees if this is a 0, it's going to pick one of these 1, 3, 4, 5, 6 text modes and say, whatever memory I see there, I'm going to try to display it as text. If this bit is set, and then it has 0 to 7 for these next 3 bits, then it's going to say, that's a bitmap mode. So instead of trying to interpret what's in screen memory as a character to print on the screen, it's going to be a pixel of some height and some width and some color that I'm going to plot on the screen. So, ANTIC mode 2 is graphics 0. ANTIC mode 3 is a custom text mode with that's 10 scan lines high instead of 8, and it's meant to let you do custom text modes with true descenders, so like a Y or a G or a Q with a descender and a lowercase. That's what ANTIC mode 3 is for. Rarely see it used. ANTIC mode 4 and ANTIC mode 5 are the multicolor text modes that use the resolution of graphics 1 and graphics 2 but allow you to do multiple colors. That's a subject for a future video, how we use those modes. We'll get to that because it's super important when you're designing games. Then we have ANTIC mode 6, which is graphics mode 1, ANTIC mode 7, which is graphics mode 2, and then we have the bitmap modes. This is graphics 3, 4, 5, 6. This is a custom mode, which is graphics 6.5. This is graphics 7, which is ANTIC mode 7. Right. This is not 7. This is 8, 12, 13. So ANTIC mode 13 is graphics 7. This is a famous mode that is used a lot in like Micro Painter and the Koala tablet and all those drawing programs. That's graphics mode sort of 7.5. It's known because you could get 4 colors with resolution of 160. It's the best resolution you can get before graphics 8. So it had the 160 by 192 with 4 colors. So that was like the best resolution to use for a long time. Then there's ANTIC mode 15 is graphics 8. It requires 4K of screen memory. Graphics 8 is the only time where you would have to set the load memory scan in the middle of your display list. Usually you only do it once at the start. The reason you need to do it with graphics 8 is ANTIC can only look at 4K of screen memory at once, and graphics 8 uses it uses almost 8K of screen memory. So halfway through a graphics 8 display list, there's a jump to the rest of the screen memory. Otherwise, ANTIC couldn't get to it. And then there's also these graphic modes, 9, 10, and 11, which are GTIA modes. The reason these have a double asterisk is because they actually use the same ANTIC mode 15 for all of these. To turn on graphics 9, 10, or 11, you have to flip a bit in another memory location for the GTIA chip, which we're not going to talk about for quite a while. So in the next video, we are going to talk about writing a custom display list and what it would look like. But hopefully this gets you a start on it and goes into some detail. Thanks. Bye.